By flying alongside and orbiting comet 67P Churyumov-Gerasimenko, the Rosetta orbiter's 11 instruments are collecting unprecedented science. And at Rosetta's first science workshop in Rome, mission scientists from across Europe and beyond gathered to discuss their findings.
The highlight for me, I think, is really the remarkable diversity of the nucleus itself. When you look at the nucleus, you see an enormous range of different surface structures. That to me was rather surprising. And what we got is something that we were able to characterize 19 separate regions in the northern hemisphere alone. And although you can group some of those into certain types, the range of structure that we see on the surface is really quite remarkable. It's in some senses it's a geologist's playground.
The visible and infrared thermal imaging spectrometer, or VIRTIS instrument, is also studying the comet nucleus.
From VIRTIS point of view, we were able to study the surface composition, and for the first time on a comet, on the surface of a comet, we observed a layer of organics which are covering the overall surface of the nucleus.
This narrow-angle camera at the Max Planck Institute for Solar System Research in Germany is exactly the same as the one on board Rosetta, which recently detected more than 100 patches of water ice on the comet's surface. Together with a wide-angled camera, it forms the Osiris instrument. A copy is inside this vacuum chamber to test commands. Apart from imaging the surface, Osiris has been monitoring the activity of dust jets in order to find their source.
We see them at various places, either as standing walls, big, huge cliffs. They of 100, 200 meters up to 700 meters. This big, huge Hathor cliff on the backside of the head lobe. But we also see many of these upright walls in the pits that have a typical diameter of 200 meters. And so these are the source, the main source region. We can't rule out flat lands, and we also have a few indication of activity in flat lands, but the driving activity is cliffs.
The MIRO microwave instrument measures dust on the surface, the development of the comet's coma, and the presence of water, producing the first map of water vapor around the comet.
We see the water coming out of regions which are usually on a boundary between an illuminated piece of the comet and a non-illuminated piece. So as soon as a shadow gets exposed to the sun, it seems to emit gas, and so we're seeing that on a number of locations on the comet.
For the scientists working across the world on different instruments, teamwork is crucial.
For me, the biggest advance is combining the data, the results, the understanding from the varied teams on Rosetta. So discussing our findings in the visible with the IR findings of the VIRTIS team, so with the sub-millimeter findings of MIRO, this has the potential to give us a real complete picture, not an instrument alone.
And almost 1 year from its first rendezvous with the comet, the 11 Rosetta orbiter instruments continue to produce scientific surprises.